What you're about to watch is one of the most ambitious and frankly chaotic supercar rebuilds ever attempted by someone outside of an official Ferrari workshop. We're talking about a wrecked Ferrari 296 GTB, a hybrid hypercar that costs well over £300,000 new, being rebuilt from near total destruction, fitted with a genuine Ferrari Challenge race kit, and then, almost impossibly, turned into something that doesn't exist anywhere else on the planet. A road-legal Ferrari that looks like it just rolled out of a racing paddock. But here's the thing. After all of that work, all of those late nights, all of those fabrication challenges, phone calls and dead ends, the car still doesn't start. And that right there is the story we need to unpack. The 296 was purchased by Matt already damaged, it had been in a crash, and from the very first attempt to get it running, nothing happened. No ignition, no startup sequence, nothing. Just hazard lights blinking uselessly and a dashboard warning that said, "Hybrid system failure, go to dealer." Which, if you know anything about modern Ferraris, is essentially the car saying you're on your own, and also, good luck. The first logical suspect was the hybrid battery system. The 296 is a plug-in hybrid with a high-voltage battery pack that works alongside a twin-turbocharged V6. That battery has its own dedicated computer, a battery management module that controls everything happening inside it. The working theory was that the crash had written fault data into this module, and that module was essentially telling the entire car to refuse to power up. The kill switch, baked into the software by the crash itself. To test this theory, the battery management module was sent off to a specialist airbag and electronics team to see whether they could read or clear any crash data stored on it. The answer that came back was not encouraging. Not a single person in that team, or apparently anywhere outside of Ferrari's own network, could communicate with those battery control modules. Ferrari has locked them down tightly. The only option, they were told, was to take it to a main dealer, which meant finishing the rebuild first, because Ferrari won't touch an incomplete car. So that's what they did. The rebuild continued. A second-hand rear quarter panel was sourced and welded in, which required careful TIG welding on aluminum, a far more demanding process than working with steel. The hybrid battery went back in. Missing curtain airbags arrived directly from Ferrari and were installed. Seats went back in. Headlights, bumpers, every single electrical connector was traced, checked, and plugged back in. A Ferrari technician had told them early on that every single component on the CAN bus system, that's the internal network all the car's computers use to talk to each other, had to be connected for the car to even think about starting. So they made sure everything was plugged in. Front bumper, rear bumper, door, headlights. Battery connected. And then hazard lights blinking. Hybrid system failure. Same as before. At 2 in the morning, every fuse in the car had been checked. Nothing was blown. The car knew it was assembled. It just refused to cooperate. Now here's where the project takes a sharp and unexpected turn. Rather than sitting on a non-starting car and waiting, the decision was made to go further. Much further. Someone had managed to order, legitimately, through Ferrari's own parts system, a genuine 296 Challenge body kit. For those who don't know, the 296 Challenge is Ferrari's dedicated one-make racing series car. It's lighter, more aggressive, and visually completely different from the road car. Wide bodywork, a massive rear wing, race specification front and rear bumpers, a central radiator instead of the road car's twin side-mounted units, and a bonnet with ventilation slots cut through it to manage heat. The plan was to bolt all of this onto a road car. A car that, by the way, still didn't start. Ferrari's parts ordering system has checks in place, structural parts require authorization, and orders are tied to VIN numbers. But for a window of time, it was possible to order Challenge kit components without those restrictions flagging. Once it became clear the parts could actually be ordered and delivered, the decision was made. They were doing it. Ferrari eventually caught on and blocked further orders, but not before a significant portion of the kit had already arrived. The fabrication work that followed was extraordinary. The rear quarter panels needed to be modified to accommodate the wing mounting brackets. A support bar that was part of the road car structure had to be cut out to make way for the wing plates, and a new aluminum support bar had to be fabricated and welded in to replace it. The rear panel, which on the challenge car has pre-cut holes for the wing mounts, had to be carefully stenciled using measurements taken from a race team's car, since Ferrari wouldn't sell them the challenge spec panel. The exhaust situation required similar creativity. The standard exhaust exits in a completely different position compared to the challenge car's layout. Without being able to source the correct titanium pipework quickly enough, a custom exhaust system was fabricated using stainless steel pipe and, in a moment of inspired improvisation, exhaust tips salvaged from a Lamborghini SVJ. This creation was immediately named the Bobtronic, after the fabricator responsible for making it work. The front bumper was even more complicated. The challenge front bumper is significantly wider than the road car unit, and it's designed around a centrally mounted radiator rather than the twin radiators that sit behind the front wings on the standard car. When they tried to fit the challenge bumper, the road car's radiators physically blocked it. There was no way to make it work without removing them entirely. So the road car radiators came out, and a race team's central radiator went in. This created a cascade of other problems: hose routing, coolant overflow lines, air conditioning radiators that now needed to be remounted in new positions, but the core issue was solved. The challenge front bumper fit. The bonnet was another challenge entirely. Race car bonnets don't use standard hinges. They're designed for quick removal in pit lane, using pin latches instead. Custom brackets were fabricated from scratch, aero-style latches from an SVJ were repurposed, and mounting points were drilled directly into the chassis legs to hold the front of the bonnet in place. It worked. Parking sensors were drilled into bumpers that were never designed for them. A registration plate lighting solution was improvised using LED strips sourced from motorcycle parts suppliers. The rear reversing camera was remounted into the challenge car's center grille position, where the race car uses it as a rear-view mirror. Through all of this, the attempts to get the car started continued in parallel. A new airbag SRS module was purchased from Ferrari for £300 on the theory that it might clear whatever was blocking the system. It didn't. Specialists from around the world were consulted remotely. Nothing moved the needle. Then a discovery during the fitment of the side skirts: 2 broken CAN bus wires were found, completely hidden in the loom, damage from the original crash that had gone undetected through the entire rebuild. Those wires were repaired. The car was connected up again. This time something was different. Instead of the usual hybrid fault message, the car immediately flagged that the hybrid battery wouldn't charge, but it recognized the connection. Progress, but not enough. When diagnostic equipment was finally connected, the fault codes told the full story. A crash data error on the EV system, an active, present fault, not a historical one. Every time a technician tried to clear it, the car rewrote it immediately. The battery's crash record couldn't be overwritten with the tools available. The same problem that had defeated teams working on new Lamborghini Revoltos was defeating them here. The software simply hadn't been developed to allow third-party clearing of these faults on cars this new and this tightly locked down. Ferrari was called. They were helpful, to a point. They suggested putting both batteries on charge separately and attempting a fault clear from there. But when the question of bringing the car in was raised, the service manager's answer created a whole new wall. Before Ferrari would allow the car on site, it would need to go through a Ferrari-approved body shop to verify and sign off on all the repair work. And with a challenge race kit fitted by non-approved methods, that sign-off wasn't going to happen. So here's where things stand. The car is functionally complete. It has been transformed from a crashed, barely there shell into something that doesn't exist anywhere else. A road-registered Ferrari 296 wearing full challenge race specification bodywork, with Vossen wheels filling out widened arches, a Bobtronic exhaust that exits straight out the back, and a rear wing that makes a GT3 RS look modest. It looks absolutely extraordinary. It doesn't start. The crash data locked into the hybrid battery's control module is an active fault that currently no third-party tool can clear. Ferrari won't look at the car without an approved body shop sign-off that the car can't realistically obtain. And ordering a replacement battery, which might solve the problem, would require Ferrari to code it to the car, which brings us right back to needing Ferrari's involvement. An email has been sent to Ferrari explaining the full situation, asking for some kind of path forward. Whether Ferrari responds, and what they say if they do, is the question everything now hinges on. After months of work, a genuinely unique machine sits complete and silent, waiting for someone with the right software to finally wake it up.